Good afternoon. Today we're going to be looking at circles, our next assignment here. And I'm not going to bother writing out the definition of circles. I'm just hoping y'all know what a circle is. And it's a formal definition. It's a set of all points equidistant from a fixed point. Let me see. Is it going to let me click on the questions, or do I have to? Just because I'm not clicking over here and getting the green checks doesn't mean you shouldn't, okay? Because you want to make 100 on the assignment, don't you? And so, and of course, if you're not here, then of course you should click there to listen to those videos. But I'm going to try something slightly different. Before I immediately start graphing circles and stuff, I want to review a little bit of factoring, okay? So just bear with me. I want to discuss how, when I say review, I'm not going to say review. I'm going to say that we are let's factor something called perfect square trinomials. Factor perfect square trinomials. We've been factoring trinomials all semester, off and on, except for the first day. And maybe even the second day, the second lesson. Okay, suppose we have this trinomial, x squared plus 2x plus 1. How would y'all go about factoring that? This is one of those trial and error ones. What do y'all think? Is it going to be pretty easy or pretty hard? This is a plus here. Let's draw two sets of parentheses. Now let's see, the second sign is plus, so what do we have? 2 of the first, so 2 pluses. Do y'all hear that? And now the first position is pretty easy. What am I going to put here and here? Just x. And I'll be darned, there's not a lot of possibilities for 1. 1 times 1. This is what's called a perfect square trinomial. And we mentioned when we were solving inequalities with cut points, if that happens, if you get the same thing in both sets of parentheses, then you better check every interval. They won't necessarily alternate. And so the reason it's called a perfect square trinomial is we can write it like this, just x plus 1 squared. That's what's called a perfect square trinomial. If you get the exact same thing in both sets of parentheses. If you're going to have a perfect square trinomial, then this second sign has to be plus. Think about it. If this second sign were a minus, then there'd be a plus and a minus, so it can't be the same thing. So for a perfect square trinomial, this second sign right here must be a perfect square. Must be a plus. And this last number has to be a perfect square. It couldn't be, say, a 6. Because if it were a 6 right here, you'd use either 1 times 6 or 2 times 3. You wouldn't be getting the same thing. Here's another one. Let's try to factor this perfect square trinomial. X squared plus 6x plus 9. How would y'all factor that?
X plus 3.
X and x. Second sign is plus, so 2 of the first. Plus and plus. And then 3 times 3 would give us a 9. 3 plus 3 would give us a 6. So this is certainly a perfect square trinomial. And we would write it like this. X plus 3 squared. Let me get all this junk out of the way here. I don't want the screen to go blank, so I'm just moving around, clicking. There. Okay, now let's try another one. Let's factor this one. How about y squared? I'll use a y instead of an x. Minus 8y plus, how about 16? Would that work out? Is that going to be a perfect square trinomial? In order for it to be a perfect square trinomial, that second sign has to be plus. It is. This last number better be a perfect square.
4 and 4.
4 and 4?
Negative 4.
Yeah. 4 times 4 would give you 16. 4 plus 4 would give you 8. Yeah, this is a perfect square trinomial. So it would be a y minus 4 times itself. So how about just a y minus 4 squared? I skipped the step where I wrote 2 sets of parentheses. Might not be obvious why I'm even mentioning this yet, but it's going to pop up. Let's see. Here's another one. Y squared minus 10y. I wonder if y'all could figure out.
5.
What number what perfect square would I put right here?
5.
Oh, you're getting ahead of me. You're getting to this point. But what would that third number need to be? A 25. If there were a 25 right here, then 5 times 5 is 25. 5 plus 5 is 10. How would I write it? Y minus 5 squared. Let's get to a bigger number. How about this one? X squared. I'll put a minus. 16x plus. Can y'all figure out what number would need to be here so that we have a perfect square trinomial? It's got to be a perfect square. Let's think. How could I figure out the perfect square? After 25, the next few perfect squares are 36, 49, 64. I think it's one of those numbers. Which one would need to be right here? If we put 36, then 6 times 6 would give 36, but 6 plus 6 wouldn't give 16. 64 is right. If that number right there were 64, then 8 times 8 is 64. 8 plus 8 is 16. So, if you didn't know this number, if you just wanted to make sure that you have a perfect square trinomial and you needed to find this number, how am I doing this in my head? Well, here's what I'm doing. Take half of that number right there. Take half. And then square it. That's the number that goes in this blank. To illustrate what I mean, suppose I had this. I want a perfect square trinomial. So I have x squared plus 20x and plus. What number would need to go right here? There's only one that would work it, that would let me factor it like that. I think I heard someone say it. How do you find it? Take half of this number and then square it. Take half of 20. Y'all just not talking? 10. 10 squared is 100. So what would this factored form be right here? X plus 10 times x plus 10. The 10 times 10 would give you the 100. The 10 plus 10 would give you a 20. And it's hard to conceive at this point that this is going to have something to do with circles and equations of circles. But just bear with me. It does.
The x minus 8 squared 64 is 8.
Yep. 8 times 8 is 64. That would be the light if you were foiling. Negative 8 times negative 8, that'd give you a positive 64. The outer and inner, negative 8x plus negative 8x, gives you the negative 16x. Okay? How about this one? Y squared minus 14y plus. Can y'all use my take half and square rule to figure out what number goes right here?
49? No.
Did you say 49? 49? Yeah. Take half of 14, that would give you a 7, and then square it. So what I'm doing right here, I'm taking half. 14 divided by 2 is 7. 7 squared is 49. And then to factor it, it's that variable. The very next sign is the one that goes here. And then just half a 14, 7. You could say this number here is either half of the middle number, or if you just want to say, okay, it's the square root of that last number. Either way. Okay. Let's not forget this as we start looking at circles. Okay? Oh gosh. No. I think I'm going to draw my circle way up here in the first quadrant. Every circle has a center point, which I'm going to call or denote with the letters HK. That's the center. Do y'all know what I mean by a compass? Not a north, south, east, west compass, but a compass for drawing a circle where there's a sharp point on one side and a pencil on the other. I remember in elementary school, we always had to buy compasses. Now I remember as kids, we were bad kids back then. We'd poke each other with those compasses, you know, wow. So, talking about violence in school, it was bad back then. And then there's also something called the radius. The radius is that distance from the center to the outer edge. If you were using one of those compasses, you would put the sharp point down on the center, and then however far over you move, that's the radius. The radius is the distance from the center to the outer edge. In order to write the equation of a circle, and that's what we're always interested in algebra, is writing equations. The equation of a circle looks like this. It's x minus h squared plus y minus k squared equals the radius squared. In order to write the equation of a circle, there's no way around it. You've got to know the center and the radius. Just like if you wanted to graph a circle. If you had a compass and wanted to graph a circle, you've got to know where to put the sharp point down, and you have to know how far to move over. You've got to know the center and radius. Well, ooh, I should have been clicking. If the center is 0, 0. This is a special case. If the center of the circle were 0, 0, then what's the equation going to look like? If I replaced h with 0 and k with 0, am I going to need these parentheses? If I put a 0 in for h and a 0 in for k, x minus 0, we could just write x squared. Y minus 0, we could just write that as y squared equals the radius squared. So there's two ways you might see the equation of a circle written. Like this, where there's no parentheses. That means that the center is 0, 0. Or if the center is some other point, like the point 2, 3, then you'll see the equation written with parentheses. Let's do problem number 1. Problem 1 says, find the center radius form of the equation of the circle with a center 0, 0 and a radius of 10. So this is problem 1. We're told the center is 0, 0 and the radius is 10. First thing we're told to do is write that equation. Okay? If we're going to write the equation, are we going to have parentheses in this equation? No, the h and k are 0. So it's just going to start off x squared plus y squared equals the radius squared. Well, what's 10 squared? 100? So what I'm going to have to type in is, and here's the answer, x squared plus y squared equals 100. X squared plus y squared equals 100. Come over here and type x squared, right arrow to get out of that exponent, plus y squared, right arrow, equals 100. And now we're told to graph the circle. So we've done some of these graphing tools, or we've used some of them already. To get started on this, I'll click right here. And you're graphing a circle, so it's pretty easy to figure out which tool to choose. Yeah, the one that has the circle drawn. It's not a line, it's not a V, which is absolute value. It's a circle. So you click circle. And it says, click the graph to plot the center of the circle. What was the center of it? 0, 0. So am I at 0, 0? If you're unsure, especially when there's such a big graph like that, look in the upper right-hand corner of that yellow rectangle. 0, 0. And now it says, click the graph to plot a point on your circle. Well, that's where you're going to use the radius. Move over, what was the radius? 10. Move over 10 units. Left, right, up, or down, it doesn't matter. I'm going to move up 10. 8, 9, 10. Have I moved up 10? I'm at the point 0, 10. Yeah. Now, if you look left and right, I moved over right 10 units. I also moved over left 10 units. And how far did I move down by doing that? 10 units. So it doesn't matter which way you go, as long as you start at the center and then move over whatever the radius is. In this case, 10. Now I'll click save. And, well, let me move this out of the way. Okay. Any questions? By the way, sometimes when there's a part A and a part B, students want to use part A to answer part B. No. Did you use that 100 to graph the equation? No. To graph the circle, you're just using the center and the radius. Okay? So they could have just said do part A before they could have said graph it and then write the equation. You're not using part A to get the answer to part B. What about problem number 2? Let me write it down. I think it's the same instructions. Find the center radius form of the equation of the circle with a center of -2, 2. And what are we told that radius is? 3? So the first thing we'll do is write the equation. Well, since the center is not 0, 0, we're going to have some parentheses in the equation. I'm going to recopy this equation right here. The x minus h squared plus y minus k squared equals r squared. Well, we're now going to plug in. What do I mean by plug in? We call the center HK. So here's H, there's K. In place of the letter H, you're going to put a -2. Watch out for those minus signs. In place of the letter K, you're going to put a +2. And in place of the R, we're going to put 3. So this isn't really hard. X minus, but right now, here's where it can be tricky. Be careful. X minus, let me lift this up. A -2. We have the minus from the equation. It's going to be a plus. Minus a negative. So do y'all see why I have a +2 here? And then y minus 2. Very good. Equals 3 squared. I'm not going to type a 3 squared. What am I going to type when I type in the answer? 9. Okay, so here's what I'm going to type in. Parentheses x plus 2 squared plus y minus 2 squared equals 9. So typing in that equation for a circle. Let's see, I'll go shift parentheses x plus 2 close parentheses, where's my exponent key? Squared, right arrow or down arrow to get out of that exponent, plus parentheses y minus 2 close parentheses, exponent, square, down arrow, equals 9. Let me see if I got that right. And now we're going to graph it. Are we going to use any of the stuff I just typed to help with the graphing? No, all you're going to use is what's given to you, the center and the radius. So I'll blow up this graph, click circle. Okay, so that center was -2, comma, +2. So that's left 2, up 2. Am I at -2, comma, 2? Yes. I'll click there. Now I'm going to move left, right, up, or down. It doesn't matter.
It's just whatever.
Yeah, however you think, how many units am I going to move? I'll give you a choice, 3 or 9. 3. The radius is 3. I'm going to move up 3. 1, 2, 3. Did I move up 3? Yeah. So I'll click there. Notice by moving up 3, I moved right 3. I moved left 3. I moved down 3. It's up to you. If you want to say you're moving up, down, left, or right. Save it. And check it. Any questions there? What about problem number 3? Oh, wait. Let's see if there's one where the numbers aren't the same. Well, okay. I'll do this one. I would prefer it to have different numbers. There's no reason why it has to be 4 and -4. I would have preferred it if it had been something like 4 and -5, but I have absolutely no control over it. And you wouldn't want it where, I can make my problems easier than y'all's or something.
If you say help me solve this and X out of it, it'll change the equation.
Yes. The help me solve it,
It'll change.
I think it works. I prefer just view an example.
I was just telling you, because you have the power. You can just say that and it'll change the equation completely.
Once you go through, I think if you just click, if you just do it like right there.
Yeah, and now it'll change it completely.
It will? Oh, shoot. I'll be darned. There's a better one. Okay, here's number 3. I didn't know that. Okay. Well, thank you. So I'm now rewriting. Here's the number 3 I'm going to do. I think it's a much better one. I had no idea. I've only been doing this, using this stuff for over a decade.
You don't have to go through the whole thing. You literally can just change it that way.
Oh, wow. Did y'all know that? I guess it just goes to show you, I never click help me solve it. Fine. Oh, you'll notice right now, it's counting this one wrong. Okay, I have a little red X. But once I get it right, it'll change to a green.
Right, correct.
Okay, so
that's the only thing. When you do that and close
-2.
out, it'll be like,
Thank you for telling me that. Okay. Now we're going to write the equation. So this is what I'm doing. I'm going to label HK. R is I already have written it, or labeled R. So parentheses x minus h squared plus y minus k squared equals r squared. So I'm plugging in the h. So that's just going to be a 5 here. So we have x minus 5. But what about over here with y minus k? It's going to be a +2 because of the minus -2. So a +2.
And then it'll be 7.
And we're going to 7 squared. So the thing I'm going to type in, x minus 5 squared plus y plus 2 squared equals 49.
That's the
Parentheses, x minus 5, close parentheses, squared, oops, get out of the exponent, plus parentheses, y plus 2, close parentheses, exponent squared, equals 49. Okay. And graph it. I'm not going to use the 49 or any of this stuff. I'm just going to use the center and the radius. So, circle. The center was right 5 down 2. Am I right 5 down 2? Yeah. And then I got to move over 7. Well, if I'm at 5 on the x-axis, if I move over 7, am I going to be at 12? If y'all could see really good, if you counted, I've moved over 7 units to the right. By doing that, I moved 7 units up, 7 units down, and 7 units left. Check it. This one's a little interesting. I don't need to hit help me solve it and change the numbers. Wow. The center is -1, 0. And the radius is 4. Well, since I don't have the x minus h squared plus y minus k squared staring me in the face, since I've switched to a new page, I'll write it down. X minus h squared plus y minus k squared equals the radius squared. So what's going to be unusual about this? Okay, so we're going to have when I plug in the -1, it's going to wind up with the x plus 1. And over here, when I plug in the 0, just y squared. I don't need to write y minus 0. Okay? I don't know if it would take it or not if I did. So it's going to be x minus a -1, so x plus 1 squared plus the y minus 0. We don't need to write anything other than just a y squared equals 4 squared. What could I write right here? Yeah, I'm just going to write 16. So parentheses x plus 1 close parentheses squared down plus y squared.
And would it have mattered if you put the y in parentheses?
That is a good question. I'm going to try it and see what happens.
I wrote it down like that.
Okay.
I guess not.
Y. If I went minus 0.
Oh, no, nothing.
Oh, wait.
I didn't care about that part.
Oh, wait. So if you put, wait, so what are you asking about?
Just wondering if just the y was in parentheses.
Oh, just the Y?
Yeah.
Oh. Like that? Let's see. Yeah, it took it. And I think it'd take it if you put y minus 0 also. Okay?
I was just making sure. I was like, wait.
Mm-hmm.
The way I have this.
Now, number 5 is just another one like this with a 0 in it. I want to get on, look at number 6. But before we do that, in algebra, you always do something one way, and then, oh wait, I haven't completed the question? Oh yeah, no, I don't want to leave it. That's crafted. I'm sorry about that. I'm getting ahead of myself. The radius was 4, the center -1, 0. -1, 0, and then 4. 1, 2, 3, 4. I moved up 4. Okay. In algebra, we always do it one way, then do it in reverse. Number 6, they give you the equation, and it says find or draw the graph. Well, in order to graph an equation, what you have to know is that center and radius. Like looking at number 3, could y'all come up with a rule to go backwards? Given the equation, find the center and find the radius. How would you find the center and the radius from this equation? Look at the answer to part A.
You do the -2 because it's positive.
Okay, so what I would say is for the x, you change the sign. Change the sign of the number in the parentheses with the x. Then look right here, we have y plus 2. The center is -2. So change the sign of the number in the parentheses with the y. And what do we do to this last number here to get that radius? Square root. Okay? That's going to be something important. How to go backwards. Given this center radius form, how do we find the center and radius? I'm going to write out a sentence. To find the center, change the sign of the number in the parentheses with the x, then change the sign of the number in the parentheses with y. So that's how you're finding the center. Change the sign of the number in the parentheses with x, then change the sign of the number in the parentheses with y. Now what do we do to the last number? That last number to get the radius? Square root to find the radius. Take the square root of the last number. In other words, all that writing to say what? Change the sign, square root. What I'm telling you is how to find the center and radius when you're given the equation. Right? Like on problem 2, we have that equation right here. If we wanted to go backwards, if we didn't know the center and the radius. Oh wait, why didn't y'all tell me to lower that thing there? Change the sign, square root. That's how you get the center and the radius. Change the sign, square root. That's going to be important for this next problem we're doing. Oh, number 6. Number 5 is just like number 4. One of the numbers is 0. There's not a whole lot of work to this one. Let me write it down. So we have this equation, x minus 2 squared plus y plus 5 squared equals 4. The instructions say graph it. Well, there's one thing. It doesn't matter if you're doing it with a paper and pencil and a compass. If you're going to graph it, what are the 2 things you must know? You must know the center, and you've got to know that radius. So that was the purpose of all that writing I was doing, trying to tell you how to find the center and radius. Oh, did I miscopy this? No. Okay. Well, this is one of those times it's probably going to look like I'm just writing down the answer. What's the center and what's the radius?
The radius will be
Okay, change the sign, change the sign. So the center is positive 2, negative 5. You see how I'm doing that? And what's the radius? 2. The square root of that last number, 2. That's what you have to know in order to graph the circle. Am I ready to graph it now?
Yes.
Yeah. Change the sign, square root. Come over here. I'll click this. Circle. See, it says plot the center. Well, we know the center. It's 2, negative 5. Right 2, down 5. Okay. Then move left, right, up or down 2 units. I think I'm going to move down 2. It'll do all of them. 1, 2. Then I'll say check it. Okay. Are we ready for another one? Change the sign, square root. If someone says, say something you learned in algebra class today. Say, Timothy Precella taught me change the sign, square root. And that's a joke because I'm not really Timothy Precella. X plus 2 plus y plus 4. This is one of those questions a lot of times students will say, well, I can do that one faster than you. I can just look at the problem and say the center and radius. Well, yeah. What is the center and radius going to be? Negative 2, negative 4. The radius is going to be 3. But I feel the need to write something down, okay? So, the center, negative 2, negative 4, and the radius is the square root of that last number, 3. All we have to do now, I'll say click. So negative 2, negative 4 is the center. Negative 2, down 4. And then I'll move up 3 units. 1, 2, 3. Any questions on this? And I sort of coerce you into agreeing with my statement that if you have the equation written like this with the parentheses, it's pretty easy to find the center and the radius. Okay? If it's written with the parentheses, like this, it's pretty easy to find the center and radius. Okay? Years ago, I went to a workshop, Avoiding Coercive Techniques in the Classroom. And I was like, oh, wow. You know, and it didn't make me avoid it. It just made me realize. I was like, oh, wow. All I ever do are coercive techniques. I try to coerce the students into going along with it. And I was just doing that. Well, y'all agree? It's pretty easy to do this.
Yeah.
What about this? Same instructions. Well, no, it says find the center and radius and then graph it. Now do y'all think, oh, he can't coerce me into thinking this is going to be easy? It's pretty easy to find the center and radius when you know or when you have it written with the parentheses. Well, here we don't have it written with the parentheses. So the natural question to ask is, can we take something like this and write it with the parentheses? And the answer is yes. And it's going to involve something we did at the beginning of class. This sort of stuff. We can take our x's, group them together, and find some number that'll let us be able to factor it as a perfect square trinomial. So, how do you do that? You take half and then square it. Okay? Don't panic as we go through this example, okay? As we do problem number 8. We write it down. Not really very difficult at all. Number 8. We have the equation x squared plus y squared minus 8x plus 2y equals 64. X squared plus y squared minus 8x plus 2y equals 64. I'm looking once again to make sure I didn't miscopy it. Miscopying it can make it much, well, besides the fact you'll get it wrong, could make it into a much harder problem. Now, our goal here is to take this equation and rewrite it so it looks like problems 6 and 7, with 2 sets of parentheses and a number on the right. We're going to do what we were doing over here, which is called completing the square. We're going to put a perfect square, introduce some perfect squares into the equation. Let's just go ahead and, I'm going to start it. You're going to start off by writing the problem, putting the x terms together. X squared, then a minus 8x, and then put a plus blank. You'll see why I'm saying put a plus blank in a moment. Next, I'm going to write the y terms. There's a plus y squared and a plus 2y. I'll put a plus blank. And we have that 64 on the right. So I'll say equals 64. But hold on. I'm about to put a number, a blue number right here. In order to keep this equation equal, both sides equal, if I add a blue number here, I have to add a blue number over here. Running out of room, aren't I? The same thing's true over here. I'm going to add a black number in this black blank. Well, I need to add it over here too. That's a plus blue blank and a plus black blank. That doesn't look like a plus right there, but it is. Okay. So what perfect square am I going to put right here? Well, what was the rule? You take half of this and square it. Take half of 8, you would get a 4, then square it, a 16. So I'm adding 16, to both sides. That's a plus 16. It might not look like it because the way I've written it so small. Let me write out what I've done here. Take half. So I'm taking half of 8 and then squaring it. And you might say, well, wait a minute, you took half of negative 8. Yeah, I did. Half of negative 8 is negative 4. But once I square it, isn't it going to be a positive 16? So I don't worry about that sign. I just say half of 8, square it, 16. Add it to both sides. Now for the black number. Take half of 2 and square it. Half of 2 is 1. 1 squared is 1. Okay. So here I'm writing it out symbolically. I'm taking half of 2. 2 divided by 2 is 1. 1 squared is 1. What have I accomplished by doing that? Well, remember, our goal is to make it look like this. The parentheses. So, let's factor that first stuff we were doing. How would I factor x squared minus 8x plus 16? Oh, it did freeze, huh? Okay.
Wait.
Taking half of the x and the y? You're taking half of the x and the y?
Because I want, that's why over here, oh, well, I can't. Okay, we'll just, yeah, you're going to have to stop it.